I'm gonna move over to L reader. So in Canvas today. Okay. I'll do something. Okay. Something wasn't loading. Today is 17th. Today is the 17th, yes.
So I was acting to put the 18th.
She's a day ahead, maybe? Because Monday was the 15th.
Probably not due till tomorrow.
Tuesday was the 16th. Today's.
I thought today was Tuesday. Okay, so it's the.
All right, so we're going to pull this together. Anybody remember the definition of a compound? We had it a while back. Nope. All right, a compound is going to be two or more elements chemically combined. So they're not a mixture because they are chemically combined. So you have to have at least two elements, and they're going to be chemically bonded together. And why do elements form compounds? We're going to learn about that today, and it is to be stable. All electrons want to have a partner, they want to be paired up, and when electrons are not paired up in an element, and it appears to be extra ones, they want to be stable. When is an element most stable? We're going to learn that today. It's when they have a complete outer energy level, which means 8 valence electrons. And give an example of a chemical formula and what it tells you about a compound. So I'm going to use water because water is one that we know, and I'm going to use this little t to the squared here, maybe. And I'm going to click on the arrow and I'm going to go down to where it's the 2 here, 2, and I'm going to click back off of it and make the capital O. So water is an example of a chemical formula. And what does it tell me? It tells me, and we've had this in previous notes, this little 2 here is telling us there are 2 atoms of hydrogen. And if there's no number beside the letter, then it is 1 atom of oxygen chemically combined. And so that's what we're going to be looking at is how do elements chemically combine. So we can get those if you will click submit. All right, we're going to do some notes, but before we do that, I want to I will be sending out an email either this afternoon or tomorrow. And inside Clever, yours may be in a different location than mine, but somewhere, and I don't know if in my page, yeah, if you click on where it says K Noel's page, there is, right here,
You have to click
big
that.
black E. I'm just showing, no, you don't have to click, I'm gonna show it. If you are currently failing, this class, you are going to be assigned, unit recoveries. So if you have failed a test and you want to make that up, that grade up, if you are currently failing from the things from last 9 weeks and it takes a while to log in. In Edmonton, that black E, you are going to see a physical science, assignment is added. And I've got to go in and finish. Right now, there's everything from quarter one. I've got to go in and lock some of it so you don't do all of it. But when yours pops up, and I don't know if I can view it as a student, you would see here your listing of courses. So if you've used this for credit recovery before, it's the same thing. But you would have a list of courses that show up, and I've added all my students to physical science or biology, and I will be assigning some, unit recovery. So for example, for matter and for atomic structure, if you did not, if you're not passing, you will have those 2 units assigned. If you failed the atomic structure, you'll definitely have that one assigned. And what it is you will have a little tutorial that you go through and then a little test that you take. And
Wait, when?
if you're passing, you don't have to worry about it. So for example, you would see this right here on yours, and I've added at least 7 students, and it would have, when you clicked on it, it would tell you their activities to do. So you're gonna have some of these, I'm gonna send an email out, and you'll get an email if you are in a situation where you need to, make up some grades, okay? So I just wanted to show you how to get to it. It's the little black E. The quickest way is if you click on K Noel's resource page, when you go into Clever, and you will see it there. So I just wanted to go over that so you know where to find it, because you'll be getting an email in the next day or 2 about that. All right, so back over here, we did not get to the notes, those that were here yesterday, we did not get to the notes. So we are going to start here. So this is kind of, we're in a unit on chemical bonding, and we are going to be, first, just an overview of what bonding is, and we have, a couple practices we're going to do today and tomorrow, and then I haven't quite decided exactly what we're going to do Friday, and then we may pick up with another set of notes on Monday. Yeah, I've given you the paper copy after you started online, so if you want to look and just make sure, I think it's submitted it, so it should be finished.
I tried to, do these.
It's probably going to be difficult.
These things, I'm sorry, I didn't really know how to do it. I mean, I copied the notes, but I didn't know how to do
Yeah.
the circles, so.
That would be good. We're going to wait for her to get back. While we're waiting for her, I'm going to go back a minute. So we're going to do the notes. And, there's a video for counting atoms that you'll need to watch. And then we're gonna practice, and I'm gonna show you how to do that. So that's kind of the goal for today. Tomorrow, there's no new notes, but there's a video on chemical bonds and ionic and covalent bonds specifically. And then we're gonna practice, just identifying ionic and covalent bonds. We may get into drawing them, we may not. I may wait and do that on Monday. So this first set of notes, I've kind of split it up into about 3 different practices. So I was hoping to get the notes done yesterday, but it just didn't work out in face-to-face setting. Are you cold? Do I need to turn the heat on? Are you comfortable?
Do what?
Do you need the heat? Are you comfortable?
No, I'm fine. I'm fine how I am. She might be cold though, so. Are you cold?
I'm almost to the point I need to turn it on for a little bit.
Oh, that's fine.
But when I'm talking, I don't like to have it on just because it gets too
We
hot.
can't even hear what you're saying.
It gets hot on my face. Let's see.
Well, okay,
So when we get to practice, I may turn it on for a little bit.
that's fine.
Table bit. Right, so when we're talking about bonding, chemical bonding, we're talking about elements combining with each other. So in nature, most elements are not found by themselves. Remember on the periodic table, if they're in column, the last column, column 18 or 8A, they'll be by themselves. They have 8 valence electrons. They do not want to be paired up with any other element. But any other element typically is not going to be found by itself. They're going to be found combined with other elements, and we call this a compound. So 2 or more elements who are chemically combined, and when this happens, it creates a new substance, and they're going to have properties that are very different from the elements that make it up. So the example we use all the time is sodium and chlorine, which make up table salt, sodium chloride. Sodium is a alkali metal right here. It is a very soft, silvery white metal, very, very reactive. It has to be kept in where air or water cannot touch it because it will react violently. Then you have chlorine over here, which is a very reactive nonmetal. It's a gas, and it's poisonous. But when those 2 elements combine, we get a product that we season our food with, table salt. So it has very different properties, physical and chemical properties when they combine. So chemical formulas, this is what we're used to tell, that let us know what elements and how much of that element is in a compound. So we used water in our warm-up. So here's water. Water is H2O, capital H, subscript 2, capital O. This is water. It contains 2 hydrogen atoms, or atoms of hydrogen, 1 atom of oxygen. The little number goes with the element that comes before the number. NH3, this is ammonia, and we use it to clean things in the house. It has a very distinct smell. It has nitrogen. There's no number by the end, so it is 1 atom of nitrogen. There's a 3 by the H, and it has 3 atoms of hydrogen. So you can actually draw these out kind of like this. So water tends to be drawn, and I usually draw it the other way, so it looks like a Mickey Mouse head. And then here is nitrogen with the 3 hydrogens for ammonia. So this is chemical formulas. They tell us specifically how much of each atom makes up that compound. You cannot change these little subscripts. If you change these numbers, you get something different. So why is it that they form compounds? We mentioned in our bell ringer to be stable. So all elements want to be stable. We have a rule called octet rule. OCT means 8. So atoms are going to gain, lose, or share electrons in order to have 8 electrons in their outer energy shell. That means they are full, complete. They're stable. They cannot hold any more valence electrons. They do not want to share anymore once they reach 8. So they're going to combine with other elements to reach that 8 in the outer energy level. This works for every element but hydrogen and helium. Hydrogen and helium is in period 1. They only have one energy level, and that first energy level only holds 2 electrons. So for hydrogen and helium to be stable, it just takes 2 electrons. So it's an exemption. Were you finished? Am I here? All right, so forming compounds. These are the Bohr models that we looked at. Remember that 2 on the first, up to 8 on the second, any remaining on the third. So if you've got 3, if it's in period 3 of the periodic table, we know that it's going to be 2, 8, and whatever is left of the proton. Because protons and electrons are equal. So in here, sodium has 1 valence electron. I think I have this kind of down at the bottom.
So you skip this part, it's gonna be here, and then you go back.
No, it was on here. Back up.
Oh, I think you did that part. Sorry.
No, you're fine.
Were we not supposed to do this yesterday?
Well, I had on the, if you'd been on the Google Meet, I had said that we probably wouldn't get to it today or yesterday. So you were ahead, so you just have to listen.
Oh, yeah, I forgot. I didn't even go yesterday. Y'all did this yesterday? No?
No, I wanted to, but the
Oh,
test
okay.
with my face-to-face folks took longer than I thought. All right, so sodium has 1 valence electron right here. Valence is on this outermost ring. If it loses that 1 electron, so if we could take that 1 electron away, it would be stable because it would have 8 electrons there on that second one. So this is the one it wants to lose. Chlorine has 7 valence electrons. It just needs 1 more to be full. So if it gains 1 electron, it will be full and stable. So it has 7. It needs 1. Sodium wants to give 1 away to be stable. So this 1 electron is going to be given over here, and the process of giving it sticks those 2 atoms together and creates a bond. So that one is going to go over here. So this is how a bond is going to happen for table salt. They're going to combine with each other. Sodium is going to give its 1 electron over to chlorine, and chlorine's going to now be happy. Sodium is going to be happy, but they're stuck together. It's like glue, and they become table salt, in which we can use on our food. So that's what we're looking at. Oops, that's what we're looking at here. So, is there a time when elements would not benefit from this? And that's yes, because this column over here, they are happy. They are loners. They do not want to associate with any other element. They don't want to share their electrons. They are very selfish. They are happy. all by themselves, their outermost energy level is full. So they are not going to form compounds. And here's examples of the Bohr models that we have looked at the end of last week on how to draw. Helium, remember, is stable because at one energy level only holds 2 electrons. Look at all the outer ones. They all have 8, so they're stable. All right, so we have 2 types of bonds. So this chemical bonding, think of it like glue. It's a force, it's holding these elements together. And so there's 2 ways it can happen. Electrons can lose or gain electrons, or they can share their electrons. But the whole point is that they're wanting to be stable. And so some of these bonds are stronger than others. So we're going to look at ionic bonds first. And this is a transfer. On that previous picture with the sodium and chlorine, that arrow, that represented a transfer. One is giving to the other to be stable. This is very important. You may want to star, highlight, or whatever. Ionic bonds are between a metal and a nonmetal. So if you look on your periodic table, you should know that metals are from the zigzag line to the left, and nonmetals are to the right of that zigzag line. So for it to be an ionic compound, if it's made up of one of these elements and one of these, it is ionic. So if you can find it on the periodic table, the symbol, and it's located here, the first one, here, the second one, it's an ionic bond. You're going to have to pick some of these out. We'll practice this tomorrow. This is going to result in ions. So what charges do electrons have? When we write electrons, what do I usually write with it? E.
Negative.
Negative. Protons usually have what?
Positive.
Positive. If my negatives equal my positive, it's going to have no charge, right?
Neutral?
It'll be neutral.
Yeah, like in the equal or something?
Yeah, when these are equal. Now, what happens if I have less electrons than protons? So think about math. If I have 2 or 3 electrons and I have 4 protons, what would my answer be if this was math?
-7. Wait, that's how we do it.
1.
1.
But how?
All right.
You're
so-
-3 plus 4.
Yes, but it's negative.
Oh, okay.
So remember, if it's negative, you subtract and take
I
the
don't know how
sign
to
of the
do it.
larger,
I'm not even good at math, so.
or you can do it on the number line. But it's going to be 1, and because the 4 is larger, it'll be a positive 1. So if an element gives up an electron, gives it away, so if the metal gives away an electron, it is going to have a positive charge. So sodium gave away an electron, it's going to be Na+. That's an ion. If it is and it's going to be called a special name. I pronounce it cation, so you may hear it called cations or something like that, but I like to call it cations. They're positively charged ions. These are the metals. So all you have to do is look at the outer ring. Magnesium has 2 electrons, so it's going to give those away. If it gives negatives away, it's going to be positive, so it's going to be +2 for magnesium. So magnesium, I think this is a fill in the blank on your notes, it's 2 valence electrons, so it will lose 2 electrons to be stable, creating a cation with a +2 charge, which would be magnesium +2. Now, anions are negatively charged. So with our salt scenario, we have chlorine. Chlorine was accepting an electron, so it's going to have one more electron than normal. So it's going to have more negatives. So we put a negative sign there for it. It's an anion. These are usually your non-metals. All right, so take this oxygen, for example. Oxygen has 6 valence electrons, and this is where you have to think, how many more does it need to get to 8? Well, from 6 to 8, you need 2, so its charge will be -2.
Oh. Wait. So if you have only 6, wait, what's the outer?
The valence electrons.
Okay, and then if you have, oh, I don't understand. I might kind of understand, but.
So each element wants 8 electrons.
So you only have 6 around there, so you need to add 2.
I need 2 more to make 8. Over here, it would take too much energy to add 6. So it's easier for the metal to give theirs away and the non-metal to take. All right, so what will this lithium form here? So look at its, how many valence electrons does it have? 1. So it's going to be just like sodium. It's going to be Li plus 1 because it's going to lose a negative. It's going to have more positive charges then. So 1 valence electron, so it loses an electron to be stable, and it creates a cation with a +1 charge, so Li plus 1. And that +1 is always up there like a superscript. Good. Oh, and here's nitrogen. So nitrogen has 1, 2, 3, 4, 5. Nitrogen is also a nonmetal. So how many more to get to 8? If it has 5, I need 3. So it's going to be a -3 because it wants to gain 3 more electrons. So it'll have 3 more negative charges than normal. So it has 5 valence electrons, so it will gain 3 electrons in order to be stable. So this creates an anion with a -3 charge. So we're going to do some practice with this over the next couple days. So if you look at your periodic table, elements in the same group, so group is a column, have the same number of valence electrons. So every element in that same group are going to form ions the same way. So in group 1, lithium, sodium, potassium, we very rarely use the ones below that. Those are the 3 main ones we use. They are all going to be plus, which represents +1. Group 2, beryllium, magnesium, and calcium, they're going to be +2 because they have 2 valence electrons. Now, this group in the middle, these transition elements, they don't follow these rules very well. They have multiple electrons that they will give away. They may give 2, 3, or 4 depending on the situation. So we kind of leave those by themselves, leave them alone. We jump over here to 3A. It is only aluminum mainly here because boron will tend to, I think, act like a nonmetal. Aluminum would be a +3. Then we get over here to our nonmetals. This is where it then becomes, it can be minuses. And so you take the group number, so 4, 5, 6, or 7, subtract it from 8, and you get its charge. So all elements in group one have one valence electron, so they will all lose one electron to be stable, forming a +1 charge. We call this charge the oxidation number. We call this charge the oxidation number. And we're going to have a whole little mini practice on finding those oxidation numbers. So lithium will be +1, sodium +1, and potassium +1. So oxidation numbers, even though we're going to talk about it today, we're going to practice it later on. This is just the charge of an ion. It is just that charge of the ion. It's going to be written as a superscript to the right of the symbol. So you'd write the symbol, then up at the top, you would put the charge. And then here is a list of the charges. Notice group 14 is interesting. Group 14 can be plus or minus because group 14 is made up of both metals and nonmetals. 15 possibly can be plus or minus as well because you've got a metal there. 16 is mostly going to act like nonmetals. And then group 17. So I think you just have to fill in the charges there on, or is it just written? It's already written.
Okay.
All right, the last thing that we will practice at some point will be electron dot diagrams. These show just the valence electrons. We're not worried about any other electron. The valence electrons are the ones that will be involved in the compounds. And so we have a shorthand method of doing this, and that's by doing the symbol and putting dots in the place of the valence electrons. So hydrogen is in group 1, it has one valence electron. Carbon is in group 14 or 4A, it has 4. Boron is in group 13 or 3A, it has 3. Oxygen is in group 16 or 6A, it has 6. Chlorine is in group 7A or 17, it has 7. So we're going to be using the group numbers to do the electron dot diagrams. So this just takes you through the steps. Like I said, we're actually going to do a practice probably beginning of next week. So when you're drawing, the nucleus is represented by the atomic symbol. All right, the valence electrons is represented by the group number. And you're going to draw dots around the chemical symbol to represent it. You fill one side at a time before, and then you pair up the electrons. So example, now the example is going to pop up, nitrogen. So you start with the symbol. You're going to look and see that nitrogen is in group 5A, so I'm going to need 5 valence electrons. You're going to start at the top. You're going to go to the side, to the bottom, to the other side, like a circle, like going around a clock. And then you're going to start with the pairing. So that is what the electron dot of nitrogen will look like. Now I'm thinking we have a few practices. And is that... Okay, we got a little bit. Did I do 2 pages of that one? No, it's a little bit different. Okay. So to practice hydrogen. So you're going to start with an H. It's in group 1. You're going to put a dot on top of that H.
Really?
So hydrogen.
Just draw the number 8, like the
So
H.
you find it on the
and then put a
periodic
dot.
table. And you're going to put an H. It's symbol. And because it's in group 1, it has 1 dot at the top. Carbon, you find carbon, it's in group 4A. It's a C, so it's gonna have a dot on each side, to have 4 dots. You always start at the top and go like the clock runs, clockwise. Fluorine is in group 7A, so it's F, it has 7. So you start at the top, go around, then you get back to the top, and you keep going until you get a total of 7. So 2, 4, 6, 7. Phosphorus is also a nonmetal. It is in 5A, like nitrogen. It's going to be a P. And it's going to have the same as nitrogen did on the previous page. You start at the top, go around, and then there's one that pairs at the top. So we're going to do more practice later with this. It's a little bit easier than the Bohr models because you only deal with the electron. And then we're going to have one whole practice where we deal with this. We're going to show how to use this to do the transfer of electrons from a metal to a nonmetal. So the first thing you would do is you would draw both electron dot figures, structures for each of the elements in the compound. Then you're going to use an arrow to show which electrons from the metal is going over to the nonmetal. You may have to add more elements of either the metal or the nonmetal to make it work. And then you're going to keep transferring until all the atoms are stable. In other words, until all the electrons around the metal has been used or sent over to the nonmetal. And then you write the chemical formula using subscripts to show how many of each element were needed. And so I think we're going to do a couple examples, but like I said, we're going to actually come back to this later and go through this again. All right. Did you get all that? Almost. Now, so we have sodium and chlorine. So we're going to do it on the board and then pop up the how it looks. Okay, so sodium, if you look on the periodic table, sodium is in group 1 and it is Na. If it is in group 1, it has 1 dot on top. Chlorine, if you look on the periodic table, is in group 7A. So it has 7 dots. So I start at the top, 1, 2, 3, 4, 5, 6, 7. So that's step 1. Then I'm going to draw an arrow. So this dot is going to go into this empty space. If this moved there, I then have 2, 4, 6, 8. That means that ring around sodium is not needed, and the previous one is full. We only deal with these last one. I only have one symbol of Na, one symbol of Cl, so that means I have NaCl. So let's see what they put up here. So you have Na. Okay, so now I know. It's going to go that way. So my chemical formula is NaCl. I think there's one more on there, right?
Then actually, yeah.
All right, now this one, we have aluminum and chlorine. Well, I can leave my chlorine here, but I have aluminum. Aluminum is in 3A, so that means it has 3 dots. Now, this is interesting because, look at this, when I move this one here, chlorine is full. That means I have to add another chlorine because I still have dots here. So if I add another chlorine, 1, 2, 3, 4, 5, 6, 7, all right? I still have one more dot here, chlorine, 1, 2, 3, 4, 5, 6, 7. This one's going to go here. It took 3 chlorines to satisfy this aluminum. So when I write this, aluminum is only 1, but chlorine I had 3, so I have to put a little 3 there. And so how it is up here, we have aluminum with 3, chlorine with 7, I have to have another one, I have to have another one, and then you get this. So like I said, we're going to be practicing that, what was it? Flip over, I think there's a practice. So for potassium and chlorine, potassium, always start in group 1. Most of the time they'll be group 1 or 2. Potassium is K. So if I come over here, and I'm going to have a K with a 1 dot. And chlorine, which we always used it, so we know it's 7. I'm going to draw an arrow, and then I'm going to write it together. So that is number 1. Oops. Oh, okay. Like that. Magnesium, I'm going to look in my first 2 columns. Magnesium is actually in the second column. So I have 2 dots. And it is going with fluorine. Fluorine is in the same column as chlorine. So it has 7. I have 1. I still have 1 for magnesium. I have to do another one. So it's MgF2. All right, aluminum and nitrogen. Aluminum is in the 3A or 13, so it has 3. Nitrogen is in 5A, and it has 5. So it's got 2 on the top and 1, 2, 3 here. All right, so 1 aluminum is going here, 1 electron here, 1 electron here. So it is ALN. Magnesium, we've used it before, Mg. It has 2. Phosphorus, I believe it's like nitrogen, it has 5. Yes, it's right below nitrogen. So I'm going to do like this. So 1, 2, 3. I need another magnesium to get my third one. Oh goodness, I need another potassium now, phosphorus now. All right, I still have 2 empty spaces, another magnesium. And so this time it's going to be Mg3P2.
Can I use the restroom after you're done?
Yeah. So the key is if you use up all of what's around the metal and you still have an empty space on the non-metal, you have to add another metal. And if you use up everything on the non-metal, you still have electrons on the metal, then you have to add another non-metal until it's all used up. And so, like I said, we're gonna spend some time, Monday looking at that. All right, go quickly to the bathroom, because we're gonna do our counting items next. Go on to the bathroom.
I was trying to fix this.
All right, I'm gonna call this up on my county. All we're gonna do on this sheet to practice is counting atoms. I have a video that you're gonna need to watch. And if you don't have time in class, you'll have to do it at home for homework. So I'm gonna get this up. All right, then, this one.
Oh, yeah, that was so good too.
Well. I may get a copy of here. Or I may not. Right in. All right, I may just write them on the Jamboard instead, since it's being finicky. All right, so if you will look at the counting atoms sheet, I'm just going to close out of this. And so to find it, for those that are remote, it's the practice for today. So you need to watch the video and then practice counting atoms. So this is what we're looking at here. I'm going to go over here to the Jamboard, and let's look at the directions. You need to be able to recognize the individual elements. So what they have up here is if I have this right here, and this is in the directions on the sheet. If there's what I call the big number that's in front of the whole compound, this is the coefficient. This is a subscript.
Does he get it?
These are the element symbols. So you have to recognize that the coefficient says there are two of these compounds. So it would be like saying, the coefficient would be like saying there is H2O and H2O. All right? The subscript is saying within one compound, there are two hydrogens to one oxygen. So to count these atoms, if I were going to count this, you could write it out like this if you wanted, or you would use the distributive property like in math, and you would say 2 times 2 is 4, so there are 4 H's. 2 times, if there's no number there, it means a 1. 2 times 1 is 1. So in this scenario here, we have a total of 4 hydrogen atoms, oh, not 1, 2. 2 oxygen atoms. I could look at it over here because it says there's 2 of those. I wrote it out. 1, 2, 3, 4, 4 hydrogens. 1, 2, 2 oxygens. So that's what we're doing.
So for number 1, can we do it together?
Yeah, I'm gonna do some of these. So you have 2 examples there. So you have NaCO3. Notice there was no coefficient there.
Yeah.
Okay? This is one thing. If there's a capital and a lowercase, they go together.
And if there's never a number beside
There's
it?
never a number, it's a one.
Okay.
And then here's the third one. So you have NA, C, and O.
She has nothing.
So 1, 1, and 3. Those are simple. But look at the second example. You have, go to another page here. 5, Z, I make my Z's like this so I know it's a Z, not a 2. N, S, O, 4. First thing I like to do is I like to write out all the symbols. I know Z and N go together. S is by itself and O is by itself. I have a 5 in front of that. I'm going to automatically go 5 times, 5 times, 5 times. Then I'm going to go here. There's nothing with the N or the ZN, so I'm a 1. Nothing with the S, a 1. There's a 4 with the O. Now I'm going to go back and do my math. 5, 5, and 20. You got a calculator on the table if you need to use it. Now, if it says, and they're showing you how many total atoms, I don't care about total atoms. I just care about you counting each one of these.
Okay, so,
Okay? So, let's do number 1.
so, okay.
So, first thing, in number 1, I'm going to write down all the capital letters that are different. Okay? So there's an N. There's 2 H's, but I'm going to write it down one time because it's the same thing. There's a C. And there's an O. So for my N, there's no number. So I'm just going to put 1. My H's, I have 2 of them. One has a 4. And one has no number. So that means there's a total of 5. My C has no
Why'd you put a
number.
4? Oh, never mind.
Because one H had
Yeah.
4. There's no number, so 1. And oxygen is 3.
So we don't have to add them all up.
No,
Good.
you can leave them like that. I want to do one. Let's do number 4.
Okay. And number 7, can you do number 7 too?
All right, number 4. So let's look at 4. Notice there's a 5 out in front. I'm going to deal with that in a minute. First, I'm going to go through and write each capital letter. If it repeats, I'm not going to repeat it. Okay? So C, H, there's another C, but I've already put a C. O, there's another O. I'm just leaving it once, and an H. All right, I know that I'm going to have 5 times on all of these because of the coefficient out front. All right, my C's, I'm going to look. Both C's don't have a number, so that gives me a total of what? 2.
Wait, why
So-
are there X's there?
5 times. There's a 5 in front of it. My H's, I have 2. One has a 3, and one has no number, which is a 1. That's a total of 4. So I'm going to put 4 here. And I have 2 O's with no number, so that is a 2. Now I'm going to go back and I'm going to multiply. Use your calculator if you need to. 5 times 2 is 10. 5 times 4 is 20. 5 times 2 is 10. Then we'll do number 7.
Thank you.
All right. There's a C. There's an H. There's an N. and an O.
So it's gonna be like 3 times basically all of it, 8, okay, so C would be 3 times 8,
8, yes.
H would be 3 times 10,
Uh-huh.
3 times 4. That was so easy, why did I need help on that? It just looks really hard.
So
to do.
24, 30, 12, and 6. So all you have to do is all the others by themselves.
Okay, so
Another
3
question.
times 8.
So now is C, then CL.
Right, the CE goes together and the CO goes together. If they, oh, we only go by capital letters.
Oh, okay.
So the CE is all one thing and the CL is one thing.
So the lowercase don't mean anything, we don't.
It just goes with the upper cases in front of it.
So which one is 3? I never mind.
The 3 goes with, all of it together.
So like number 2, it says C lowercase e, you
Uh-huh.
do CE.
CE,